At JaiaRobotics, our goal is to be able to give every Naval and Marine Corps vessel the ability to characterize their own environment to determine whether or not that littoral environment and surf zone is safe to transit through. The Recon Marines are typically tasked with doing a confirmatory beach report, and within that report there are 3 sub-reports that go into that. And those 3 reports are a beach survey, a surf report, and a hydrographic survey. A hydrographic survey determines the depth and gives you bathymetry of the sea floor as you're making movement towards the beach. A surf report determines what the characteristics of the waves are, how big the waves are, and how they're going to influence a maneuver force. And then the beach survey is intended to be able to identify key locations on whether or not the beach is suitable to actually not only get to shore, but then being able to progress further into the hinterland to continue the operations. Currently, we are utilizing these very rudimentary techniques to execute a lot of these mission sets. So traditionally, you would put a platoon full of 24 Recon Marines in the water. You would put them on small boats, get them to about 2 nautical miles off the shore, and then they would start swimming in until they get into the area that they actually want to survey. So one of the most important things about a hydrographic survey is we got to get the depth data. The way that we do that is we swim these knotted lines, and the 550 cord line is got a little knot in it about every foot. And on the end of it is a little lead weight to make sure the line obviously goes all the way down and makes contact with the seafloor. So once we actually get to the spot that we want to take a depth reading, we'll lower that line and it'll make contact with the seafloor, and then we count those knotted dots as they come up and as we feel them, right? So we'll pull it up, we'll put it around our hand, and then we'll tell our buddy, hey, that was 15 feet at that area. He'll write it down on his swimmer slate, and then we go to the next point. After all the depth data is recovered, we then have to determine what the currents are doing. The currents are some of the most important information because as a boat is coming into the surf zone, we need to know how that current is going to influence that boat. So it lets the boat commander know what angle of attack he needs to take when he's coming into that surf zone. Because if he is off with the currents and he's not perpendicular with the wave line and with the currents, that boat can very quickly flip over. The way that we're doing current data and the way that we still teach it today is to put a floating object like a water bottle in the actual littoral environment, and we have Marines mark on the beach a start point and an end point. One Marine will throw the water bottle in the water, and this is at night, and then we do a quick time distance calculation and make a determination on what the speed is of that littoral current. You can obviously see this is one of the most important and crucial variables that we collect, and we're using a water bottle. The wave height is also very important because a boat commander needs to know what is the biggest wave that he may encounter during his ingress from the ship to the shore. This is important because we like to tell him what the worst case scenario is that he might face. The way that we teach this currently is we say, imagine you are standing on top of the water and try to visualize where that wave would hit you on your body, and based off of how tall you are, try to make an assessment. Was that a 2-foot wave? Did that hit your knees? Did it hit your waist? Was it a 3-foot wave? And so after swimming 2 nautical miles in, after planning a mission for 24 hours, we're asking our young Marines to make an accurate assessment of wave height to determine if a surf zone is safe for a specific vehicle to transit through. My life has definitely been in jeopardy on a confirmatory beach report on multiple occasions. If we can minimize the risk to that human life, to that family that's expecting that husband to come home, if we can minimize that risk not only to the force and to those men, but the risk to the mission as well, the information that we're collecting and the time that it takes, it's not as accurate as the information that we can collect currently. So when we have the option to put something like a robot into the water to collect the information instead of a human, we should be doing it.
We designed the JaiaBot Hydro and the JaiaBot PAM with a warfighter in mind. That mission was to fulfill the Marine Corps' need to safely negotiate the littoral maneuver and beach landing sites that they were having real problems in navigating. The JaiaBot system can be deployed from virtually anywhere. The shore, a boat, even a plane. It can transit at top speed for an hour, so it can go between 7 and 10 miles. We transit on the surface, we punch out through the waves, and we've actually punched out through 10-foot waves on the Pacific coast. We then dive down to the bottom, measure the depth, come back to the surface, move to the next point, rinse and repeat. While we're on the surface, we're moving up and down with the waves, and we're measuring the wave height. We also drift in between dives to measure the current vectors in the surf zone. So we can provide bathymetry, bottom type, wave height, wave period, and the current vectors in the surf zone in order to enable smooth, safe, and effective littoral maneuver and amphibious operations. That data is real-time data. It's scientific data, not subjective data, and it's available at the speed of need. I can throw 8 in the water, within 30 minutes I know that's a safe landing site. And I can mark that safe landing site with ingress and egress routes by stationing the JaiaBots so that they give you a path to follow into and out from the beach. If I was to plan an 8-vehicle mission to operate in the surf zone, by using the tools that we provide, that takes less than a minute. I can plan that in the lab, I can plan it on the beach, I can plan it on a boat. Super, super simple. Training takes between a day and a half. We've trained over 100 Marines. And it's not just recon Marines, it's logistics, it's infantry. The feedback we've had from the Marines is, wow, this is easy to use, and they love it. Jaia has an efficient, effective, capable solution that can be delivered at scale and provide the capacity to do the job really, really well. We can scale to deliver 1,000 JaiaBots in less than 12 months at a cost of just over $10 million. That will outfit the first initial operating capability for the Marine Corps. Recon and maritime. It's an absolute no-brainer.